Welcome to the Glacier Notes, and these, I guess, if anything, would be a continuation of the erosion notes. We had parts 1, which covered the basics of erosion, and in part 1 it also talked about gravity and wind. In part 2 of the erosion notes, we talked about running water, and I guess this is Glaciers part 1, or if you want to call it erosions part 3. And we're going to be talking about glaciers. In fact, we'll probably separate glaciers into two different parts as well. Now, if you're asking why do we have all these different parts, well, I'm trying to keep these videos shorter. If I was to be giving the glacier notes in class, it would probably cover at least one full class period, if not part of another class period, because when we have the slides up, kids are asking questions. And with these flip videos, the kids don't have the opportunity to ask questions. Although, if you're watching this video, as always, if you have any questions about what's going on or any concerns or something still puzzling you, when we get to class the next day, just ask. And we can go over it as a class, or we can sit down and go over it individually if you want. So these are the Glacier Notes Part 1 or Erosion Notes Part 3. And I am giving these from the perspective of Wisconsin. I am from Baraboo, Wisconsin. I am a 8th grade middle school science teacher. So when I'm giving these notes, by no stretch of the imagination are these notes intended to be all-encompassing. They're just a brief survey of how glaciers have impacted Wisconsin. So a few glacier facts. 1. Presently, about 10% of land area is covered with glaciers. And during the last ice age, scientists have estimated that approximately 32% of our planet was covered by glaciers. So when you look at that, or at least 32% of the total land area. So when we look at that, during the last ice age, there was a lot more ice covering our planet. And there are some geologists who theorize that at one point in time, our entire planet was actually covered with ice. So even when we go into an ice age, a lot of the planet's covered by ice, but it's not as much as some scientists have theorized had covered the planet at one time. And with only 10% right now, we don't have a lot of ice on our planet compared to other times. Now, Antarctic ice is about 4,200 meters thick in some areas. So you're looking at something that's several miles thick. So the ice is getting extremely thick in certain parts. The glaciers store about 75% of the world's fresh water. So that's an interesting fact. You know, living in Wisconsin, you have the Great Lakes, and you see Wisconsin being, home to like 12, 14,000 lakes. So you see water all over the place, but most of the water on our planet is locked away in glaciers. And in states like Washington, glaciers produce about 470 billion gallons of water each summer. And if all the land ice were to melt, sea levels would rise approximately 70 meters worldwide. So, glaciers. What is a glacier? A glacier is a large mass of slow-moving ice and snow. And glaciers originate where winter accumulations of snow exceed the amounts that melt during the summer. So here in Wisconsin, we get snow every winter. We just had a big snowstorm not too long ago. But every spring, come spring, and definitely into the summer, all the snow melts. So we're not going to get any glaciers forming here in Wisconsin. However, if for some reason the summers were just a little bit cooler and we had more snow happening during the winter months, and if over time the snow would survive all summer and then it would survive into the fall and then survive into next winter, and then winter accumulations kept adding up and adding up and adding up, we could get glaciers in Wisconsin once again. But that's not too likely now with our current climate. Now, there's two different types of glaciers. One is a valley glacier, and if you look at a valley, look at the title of it, valley glaciers. These are found in mountainous terrain. So a valley glacier is found in mountain valleys. You find these all over the planet today. You can even find glaciers on the equator as long as they're on top of a mountain and it's high enough in altitude it's going to be cold enough. Now, a continental glacier, if you look at the name, again, a continental glacier is just what the name implies. It's a large glacier that can encompass all or parts of an entire continent. So here we see a nice valley glacier coming down, and this would be an example of what a continental glacier might look like, or at least the area that it would cover. So how do these glaciers move? Well, there's a couple ways that they can move. One way is called basal slip. This is when the ice in the glacier partially melts due to the weight and the pressure of the glacier on top of it. So if you can imagine a glacier being pretty thick, and that glacier is thick enough so that all the pressure from the top of the glacier is pushing down on it, it can cause the bottom of a glacier to actually partially melt. And then if as long as you have gravity again, some of that glacier, it's going to slide on that layer, that thin layer of not molten, but melted ice, which is now water. Now, plastic flow is another type or another way that it can move. Plastic flow is when the ice crystals in the glacier, they realign themselves and then they slide on top of each other. And that's one of the reasons why the top of a glacier tends to move faster than the sides of a glacier or the bottom of a glacier. So here we see that right here. The tops and center sections move faster than the bottom and side sections of glaciers. And this is where I would ask you, if you were in class, why? Why do the tops and the centers move faster than the bottom and the outsides? And this is where you would tell me it's because of friction. And you're absolutely right. The bottom and the sides of the glaciers are coming in contact with the rock of the mountains, of the valleys that they're moving through. So there's going to be more friction there than you would find in the center section or the top section. So here's an interesting slide. This is the same valley. Now, when the glacier moves faster than it melts, the glacier is said to be advancing. And on the top, you see that the glacier has moved down into the valley. But the same valley, later on, you can see the ice is melted away. So when the ice melts faster than it's at it, it says to be retreating. So do the glaciers actually have legs? Are they walking? Are they moving in that sense? No. It's just that the winter accumulation is more, it's accumulating faster than it's melting. And if it's moving forward then as a process, or as a, what I want to say, I don't want to say as a fact, but as a result of it, there being more snow accumulations, we say that it's advancing. And if it's melting faster than it's snowing and moving forward, we say it's retreating. Now, ice ages. When winter accumulations of snow exceeds the amount that melts during the warm seasons for a prolonged period of time. So we're just not talking about a year or two, we're talking about hundreds of years and even to centuries. We call these episodes ice ages. Now, there's several causes of an ice age, or at least scientists believe there's several causes of an ice age. One, the Earth's orbit changes. About every 100,000 years or so, approximately every 100,000 years or so, the gravitational pull of the sun actually pulls the Earth's orbit, and it's slightly more elliptical. And as a result, if it's slightly more elliptical, there are certain times of the year that it's going to be a little bit further away from the sun. And it's going to be far enough away from the sun where it's going to change the climate, and it's going to make it slightly cooler. Now, we also have the inclination, or the tilt of the axis. The Earth's axis tilt, or the inclination, changes approximately every 40,000 years. And today's tilt of 23.5 degrees means we receive more solar energy right now than if it didn't have that much of a tilt. And during the Ice Age, our tilt was less than 23 degrees. So it was colder. So we're not talking about huge differences in the tilt of the Earth. It just says that it was less than 23.5 degrees. But it was enough, along with the elliptical change in our orbit, to cool off our planet. And then, so here we can see the difference. So if I pull out a pen here, let me change that to a pen. So we can see if it's 23.5 degrees approximately, there's certain times of the year where we're going to get more sunlight. I'm not going to say we're going to get more direct sunlight, because it's always going to be direct sunlight, you know, as it comes from the sun, but it's heating up less area, less surface area. But if it's less than 23.5 degrees, in other words, it's moved this direction, actually this one's moved in this direction, and because we're a little bit further north, we're still going to be getting direct sunlight, but it's not going to have to heat up, it's going to have to eat up a larger surface area because we're further north. And as a result, it just cools off the planet just enough. And again, if you throw in the slightly more elliptical change in our orbit. And there's one last thing I want to talk about, and that's the albedo effect. This is, now some of you might be saying, well, hey, I've seen albedo spelled A-L-B-E-D-O. I've seen it spelled both ways. So we're going to go with this way. And again, if you are typically used to spelling it the other way, I've seen it both ways in different books. So we're just going to go with this way right now. So the albedo effect is the prolonged cold resulted in cold summers, so the snow does not melt. And as a result, the snow itself, being white, will actually reflect a lot of that sunlight. For example, if you're out, you might say, I don't need my sunglasses in wintertime. It's not that sunny out. But if it snowed out, you typically need your sunglasses when you're driving or if you're in a vehicle, because all that sunlight is reflecting off of the snow and it's pretty bright. Well, if you can imagine our planet having a lot more snow. And so when that sunlight's coming down and hitting our planet, a lot of that sunlight, a lot of that energy is reflecting back up into the atmosphere. And as a result, that actually cools off the planet. So if you take a look at all three of these things, these slightly more elliptical change in our planet's orbit, the slightly less inclination of the tilt of the Earth, and you look at the albedo effect, all three of them tend to cool off our planet. And the lighter colored land masses had cooler temperatures that mix with the warmer air from over the darker colored oceans, and the result, you're going to get an increase in snowfall as well. Now, there's been 4 major advances of ice sheets during the last million years or so. And they've named each of these major advances after a state in which they found a great amount of evidence. So there was Nebraska, the Kansas, the Illinois, and then the Wisconsin. So here in Baraboo, we see a lot of those glacial features right here in Sauk County. And scientists believe that the last ice age came in about 70,000 years ago and left Wisconsin somewhere around 12,000 years ago. So when you look at YBP, that just means years before present. So here's so if you look down here, it's not going very much. In fact, here we go. We got 10, we got 9. So you can see over time 8. So it starts at 18, 14. And that's K is 1,000. So if you've ever heard of 10K, that means 10,000. So 1,000 years before present. You can see that the scientists believe that the last ice age actually originated someplace in Canada that's covered our continent. And eventually it melted back to that point. Now, one thing I do want to point out is if you're in Europe, you're not going to hear about the Nebraskan Ice Age or the Kansas Ice Age or the Wisconsin Ice Age. These names are primarily for us here in the United States and in North America, because that's where the most evidence is found here. If you go overseas, they're going to call it different. They're going to call the ice ages something different. Now, each advance was followed by a prolonged recession from the glacier, which is called an interglacial period. And each glacial period is named after the state in which the greatest evidence of it is found. And this interglacial period is something I want to point out. When I was back in college, back in the 90s, I don't want to date myself, I'm getting pretty old. But back in the 90s, my college professors, my geology professors, kept talking about how they believe the ice age is coming, that we're just in an interglacial period. Now all of a sudden, in about the year 2000, and after that, we started hearing about this another global phenomenon called global warming. And so it leads a lot of geologists. A lot of geologists, they say absolutely this is happening or this is happening or this is happening. The bottom line is we don't know. 20 years ago, oh yeah, the ice age is coming. We're just in an interglacial period. Now, oh yeah, global warming is happening. Oh, the planet's going to keep getting hotter and hotter. Thing is, things change. No one can ever say with 100-degree certainty that this is exactly what's going to happen. And that's the great thing about science. Science evolves depending on what evidence is there, and it's always based on the best evidence of that time. So in the early 90s, yes, it did look like the ice ages were coming, that we were just in an interglacial period. And then there was this global warming evidence. So we'll have to see. It might be that I'll be creating new videos in 30 or 40 years talking about some new phenomenon that seems to be happening on our planet. Now, the Wisconsin stages of glaciation. The glaciers first entered Wisconsin about 35,000 years ago, or at least geologists theorize that. And they theorize that it left Wisconsin approximately 10,000 years ago. So it probably left the Baraboo area about 12,000 years ago. Now, there was 4 major lobes that came down from Canada. And each one of these lobes, it's kind of, and we'll go in and we'll define lobe in a little bit, but think of it as being like a glove. And each finger of this lobe kind of covered and helped create a different part of Wisconsin. There's Lake Michigan lobe, and this Lake Michigan lobe created Lake Michigan. Before this latest lobe came down and scarred out Lake Michigan was always it was lowlands, but it was more of a marshy area, kind of a swampy area. But this last glacier came down and it actually gorged out a lot of the lake, which, when the glacier melted, and a lot of that meltwater actually helped create Lake Michigan. So without this last major ice age, we probably wouldn't have any of the Great Lakes. They'd all be marshy areas, which wouldn't be good to build on. It really wouldn't be good to build roads over. So it'd be interesting. It would have been very interesting to see what would have happened if we didn't have this last major ice age, to see how we would have built around and how we would utilize that land. But unfortunately for us, we do have the Great Lakes, and they're a great asset to us here in Wisconsin. Then we have the Green Bay lobe, and I'll show you a map of this, but this lobe came down, created the Bay of Green Bay, Lake Winnebago, Horicon Marsh, and the hills around Madison. So if you hear things like the Horicon Marsh, if you've ever been there, it's a huge marsh, but that marsh once was a huge lake. And through succession, it's starting to fill in. And if you know anything about Lake Winnebago is not a very deep lake. And it might be another Horicon Marsh in several thousand years as it starts to fill in. We've got the Superior lobe, which created Lake Superior. We got the Chippewa lobe, which worked over north central Wisconsin. And then there's the Wisconsin Valley lobe. This tends to be one of the smaller lobes that came in Wisconsin, and it moved into the watershed of the upper Wisconsin River. Now, as we look at this map, you can see the different fingers that have come down. So when I talked about a glove and having the different fingers, it kind of looks like a glove here, but imagine this as being your Green Bay lobe. This is your Lake Michigan lobe. You got your Superior lobe. And then even within here, you can take a look at some different lobes. So these did come in, they scarred out Lake Michigan, and after they melted, they left a lot of this water behind to fill the Great Lakes. So here we see these different parts. So you got your Superior Chippewa lobe. I didn't mention the Langlade lobe before because it didn't have a pronounced impact on a great part of Wisconsin or a large part of Wisconsin, but it did help shape part of northern Wisconsin. Here in Baraboo, we would have been covered by the Green Bay lobe. We're actually right in this here area is Baraboo, and part of the area around us was covered by the last glacier, and part of it was not covered by the last glacier. So a lobe is a finger-like extension of an ice sheet. Now, Wisconsin can be divided into two areas. It can be divided into the glaciated area of Wisconsin. We can also divide it into the driftless area of Wisconsin. And when we look at those two, the glaciated area covers about 2/3 of Wisconsin, mainly the northern part of Wisconsin and the eastern part of Wisconsin. And the non-glaciated area, sometimes called the driftless area, covered about 1/3 of Wisconsin, mainly to the south and to the west of Wisconsin and to the southwest part of Wisconsin. So when we look at this right here, you can actually see the area that tended to be glaciated. It tends to be this area in here, and you can start to see it. This area that seems to be flatter in here, and you're going to have some higher lands here that was covered by your Langlade lobe. But you can see these areas in here tend to be flatter. They were covered by the last glacier. The glacier, acts a lot like a plow, leveling out areas, rounding off the tops of mountains. Where this area in here that has a lot more valleys and a lot of coulees, a lot of rivers running through these steep valleys, this is what we call the driftless area. This area was not covered by the last few glaciers that came through Wisconsin. So here's a different map of it. So you can see the driftless area, and then you can see the area that was covered by the last glacier. So the causes of the driftless area. Why did the glaciers come through and cover all Wisconsin? Why did they cover, go more to the south in one part of Wisconsin, but not the other part? Well, first of all, the highlands of the north tended to slow down the Chippewa Glacier lobe, so it couldn't get as far down to the south as some of the other lobes. We also know that the Green Bay and the Lake Michigan lobes to the east and to the west, they simply moved faster. Not all lobes moved at the same speed, regardless of whether they had the highlands slowing them down. And so they moved faster than this Chippewa lobe. and then the glaciers began to retreat before the area could be covered. So if the glacier would have happened for thousands of more years, eventually it might have covered all of Wisconsin, but that didn't happen, and the reason it didn't happen is because the climate started to change, started to warm up, and now more of that snow is melting. So much of the current landscape of Wisconsin was formed during the last major ice age. And the western part of the Baraboo Bluffs is part of the Driftless Area of Wisconsin, Minnesota, Illinois, and Iowa, which have not been glaciated for at least 750,000 years. So we've probably been covered by glaciers in the past. In fact, it's pretty much a certainty, just not recently. Now, we're going to end this part. This is going to be the end of Part 1 notes. But I'm going to end with one question for you. And, well, I guess I'm not going to end here. I'm going to do a few more slides. But one of the questions I was going to ask you is, were the bluffs created by the glaciers? And a lot of times when I ask my students this, a lot of times I'll ask them I'll ask them like this. I said, how many of you knew that the glaciers were created by, or the bluffs were created by the glaciers? And most of them will raise their hands and say, yes, I knew that. Then I have to give them the old, that's wrong. The glaciers did not create the bluffs. The bluffs were always here. Now, the glaciers created a lot of landforms around the bluffs, but they did not create the bluffs themselves. See, the eastern part of the bluffs were covered as recently as 12,000 years ago by the glaciers, but not the western part of the bluffs. And the glaciers, they did transport in a great amount of rock and soil debris. Some of this debris, which is called till, was piled up at the margins of the ice lobe to form moraines. And we can see those terminal moraines right here in Wisconsin. And we can actually follow that terminal moraine all the way out west and all the way out east. So we see a lot of glacial features here in Wisconsin, but the glaciers did not create the Baraboo Bluffs. So what is a moraine? A moraine is a ridge formed by the gravel, sand, and the boulders carried along by the glaciers, and they're deposited at the outer edge or front of a glacier. Now, some of these moraines can be as 10 feet high, not very high. Some can rise up to 300 feet high. For example here, this is an animation of one or a drawing of one. So think of this glacier as being a large snowplow. As that glacier is plowing over the land, it's picking up a lot of rock debris. Now, as it starts to melt and it loses that energy of motion, what's going to happen at the front? Imagine if this was a snowplow. If you had a snowplow moving stuff in and all of a sudden that snowplow stops and puts itself in reverse, all the snow is left behind. Well, the glacier is going to do the exact same thing, and it's going to create these huge ridges. And for example, if you've ever been out by Devil's Lake, this is one of the roads that goes through Devil's Lake State Park. It's a DL. And you can see how tall this moraine is. And this is considered to be one of the terminal moraines. This is the furthest, marks the furthest extent of the Green Bay Lobe as it came through this part of the state. And here's a view from the top of another part of the lobe. Here's the terminal moraine of Lake Michigan Lobe, the same terminal moraine. If we would follow it, we could actually follow it all the way out to the Great Plains and all the way to the Atlantic coast. Now, this does end part 1 of our notes. And again, a lot of times students have questions about glaciers. And again, this video is only going to be a small survey. If you've ever taken any geology courses at the university, you know that you can take an entire semester on glaciology, and you can study glaciers and their impact on our society and their impact on landforms, and you can spend a lot of time studying it. Where this is just going to be a quick 20, 25 minute, 30 minutes total with parts 1 and 2. Brief introduction of glaciers and their impacts, mainly here on Wisconsin. So if you're one of my students and you have any questions or anything you want to share about this video, just ask me when you get to class. I'd love to talk with you about it. And again, as always, thank you for taking these notes. Bye.